All right, so this is the intro to lesson 3. And these are the materials that you're going to need. This is going to be a short video. You need the little piece of graph paper, a ruler, you have to have a pencil, and a piece of patty paper. First thing what I want us to do is this. I want us to draw an X and Y axis. Basically, I want to draw the coordinate plane onto this piece of patty paper. And it doesn't have to be perfect. The reason why the graph paper is so helpful is so that you can see the lines to draw so that they're accurate. So I have that. I've done that. And I'm going to draw a horizontal axis. It is going to be very important that you label. We're going to label everything. So I just estimated where the center was. Now I'm going to label this your x-axis and this as the y-axis. It's really important because this is a square piece of paper. In a little bit, you're going to need to distinguish between the quadrants. And just as a reminder, this is quadrant 1, this is quadrant 2, this is quadrant 3. Oh, I moved it and I didn't want to do that. That's quadrant 3 and this is quadrant 4. Now, the other thing I want you to do is I want, using the graph paper, line up. Let's line that up. Okay, I want us to go ahead and put some markings as well on our patty paper. And by the way, why is this called patty paper? It is called patty paper because this is the type of paper that separates hamburger patties when you buy the hamburger patties. All right, so just again, the only purpose for the graph paper is so that we can draw our coordinate plane as accurately as possible. So there's that. All right, now I don't need the graph paper anymore. So and it maybe not. I mean, it doesn't matter here in just a minute. You might want to use it again, but we'll see. What I want us to do is I want us to draw on our piece of patty paper the equation y equals 2x plus 3. Okay, so I want us to draw using our pencil. It has to be a pencil. I want us to draw the line. I hope you remember that that's a line. Y equals 2x plus 3. So the y-intercept is 3. So 1, 2, 3. Here's our point. And our slope for this line is 2. So I will go up 2 and right 1, up 2, right 1. Now, if you don't, there's no reason why you could not have kept your graph paper underneath this. But anyway, down 2, left 1, down 2, left 1. Now, we are going to, once we get several points, we're going to take our ruler and I want us to draw. See, that doesn't look right. Hold on. And we'll put this on here. It may just be because I made my dot so big. From here, I went down 1, down 2, over. I think this is a little bit too far down. Okay, if I had followed my own instructions. Okay, so down 2, left 1. There we go. Sorry. So now I'm going to take my ruler, and I'm not just going to draw my line like this. I want to extend my line. I want to extend this graph all the way through the patty paper. Oops. So here's my line. Y equals 2x plus 3. Okay, so this particular lesson is all about inverses. This is all about inverses, a function and its inverse. So what we're going to do with this patty paper is we're actually going to create the graph of the inverse of this function. So what we need to do now is this, and I think it'll help if we graph also the mom and daddy line. Now the mom and daddy line is y equals x, which means our point is at the origin. The y-intercept for this is at the origin, up 1 over 1, up 1 over 1, 1 over 1, up 1 over 1, and so on. Down 1, left 1, 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 down 1, and so on. Now I'm going to draw this mom and daddy line. And the only reason why I'm drawing this is to help when I want to create the inverse. So we've taken y equals 2x plus 3. This is a function. And now what I want us to do is I want us to create the graph of the inverse of this function. And the way we're going to do that is we're going to take our patty paper and we're going to fold the graph over the mom and daddy line. So in other words, here's the mom and daddy line. I'm going to fold my graph. I'm going to fold the patty paper over the mom and daddy line. Now, when you do this, you see how your paper is not necessarily, it might, but it might not match corner to corner. It's not necessarily a corner to corner thing. It might be, but it doesn't have to be, depending on where you centered your graph. So here's the thing. Now I'm going to put a crease there. If you open this up, the crease should be laying right there on the mom and daddy line. So fold this back over, and now what we're going to do is I want you to either take your fingernail or a coin, and I want you just to go over with that coin. I want you to just kind of press down. What you're doing is you're transferring the graph of the original function that we had there. Okay? Well, let's see. So I'm just going over the line that I had drawn. And now I'm going to open this up. And what you should see, I'm going to close it because right in here is not, it didn't transfer very well. I'm even going to flip this over and do this side. Okay, so now I'm going to open my patty paper up and I'm going to make sure that I have, this is my x-axis, this is my y-axis. So what we've done is we just created the graph of the inverse of this function. So this graph, the image right here, is of the inverse. And sometimes, not sometimes, but we note the inverse of a function using what looks like a little exponent, y inverse. Okay? So how did we create the graph of the inverse of this function? We did that by taking this graph and transferring or reflecting the graph across the line y equals x. When we folded this graph along the line y equals x and we transferred the image, the result is the inverse of that function. Okay, so right now all we need to know is how did we create the graph of the inverse. All right, so now what I want us to do is take another piece of patty paper Took me a minute. Sorry, I had to go get another piece. Now I want us to take another piece of patty paper, and we're going to do the same thing, but with a different function. So draw your X and Y axis. Okay, and then just kind of find what looks to be the center. Label the X and Y axis. That's X, this is Y, and do your tick marks. Okay, and now what I want us to do is I want us to graph Y equals X squared. Okay, so this is a quadratic function. It's actually the mom and daddy quadratic function. And so hopefully we don't need to create a table, but if X is 0, we have a point here. The point when X is 1, Y is 1. When X is 2, Y is 4. And let's say 4, 5, 6, 7, 8, 9. 1, 2, 3. When X is 3, Y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And based on the symmetry and based on the fact that Y equals X squared is an even function, we know that each of these points, except for the vertex, will have a partner directly across from it. And then 1, 2, 3. Okay. So I'm going to draw my parabola with arrows at the ends. It's not too awfully bad, but ooh. All right, and now I'm going to let's see. What I'm going to do is I'm going to draw the mom and daddy line. So 1, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And let's see. So here's the mom and daddy line. And again, I'm just using that. I'm just going to use this so that I can have a visual to fold the graph over the mom and daddy line. I want to create the graph of the inverse of this by folding this graph over the mom and daddy line. Mom and daddy line. Make sure I'm happy with my fold. Yep, not bad. And now I'm going to take my coin or my fingernail, either one, and I'm just going to draw over the graph. I just want to transfer the image. All right, now I'm going to open it up and see what it looks like. And I can see the image fairly well. So what I've done is, sorry, I got a little crooked there, but here is the x-axis, there's the y-axis. My original function is there, and the image of the inverse of this function you can see here. Okay, so how have we created the graph of the inverse? So we created the graph of the inverse, we transferred the image of this function across the mom and daddy line, or the parent function y equals x, And when you fold or reflect a graph about something specific, what does that create? It creates symmetry. So what is the relationship between a graph and its inverse? The relationship is that inverses are symmetric with respect to, what did we fold the graph over? We folded it over the line y equals x. So the biggest characteristic between the relationship of inverses is the fact that the graphs will be symmetric with respect to the line y equals x. So that's the point of this activity, is just to understand what the relationship is between a graph and its inverse. And the relationship is, once again, that inverses are symmetric with respect to y equals x. Okay? All right, so that concludes this video. We will continue with lesson 3.